Hello everyone, in this video we will show you our simulation project. This is an improvement project regarding material reception and unload. We'll go through the following tasks: problem definition, flowchart, data, distributions, model, verification, and results. P&G is the #1 company in the consumer goods market. In the Prjecto industrial complex, the company produces different products of its own brands in the fabric care and home care lines that are distributed throughout Mexico and abroad, including the USA and Latin America. As the current system works fine, we will make an improvement proposal aiming to lower operation cost while keeping the current capacity of the process.
The trucks can contain liquid, bulk, or packages, which have a different destination within the complex. Circulation routes are already established within the company facilities for the delivery of each material. Trucks can contain bulk on load into reception hoppers, those with liquid in tanks in the liquid section, and packages go directly to the container and packaging warehouses. The flow of the trucks is as follows. The trucks arrives at the industrial complex, pass through the porter's lodge to be inspected and checked. Actually, there are 4 porter lodges, then go to the weighing area, which there are 4 scales, and they proceed to the respective unloading areas. Before each unloading area, there is a setup process. There is 1 parking spot before the setup process for every kind of truck, so there can only be 1 truck waiting for the setup process beside the truck being attended. Once unloaded, they are checked at the porter's lodge before leaving the complex. Data was provided by the company's recorded arrivals. They provided arrival records and process manuals. Arrival records were processed in Excel to obtain the time between arrivals in order to later obtain a matching statistical distribution. Manuals state the times operators take to complete certain tasks. These were already provided in either a uniform or triangular distribution. According to the data analysis we did and the goodness fit test, the distribution that best fit the arrivals and unloading processes are the following. In order to obtain the statistical distributions, we used an app called EasyFit. It provides us with a graph with the goodness fit and the parameters of each distribution. For the arrivals, the distributions that we obtained were Pearson seats. And for the unloading processes, the distributions were beta, normal, and uniform.
So once we have our statistical distributions, we can proceed to create the model. We have 3 types of model entities: a truck containing liquid, a truck containing packages, and a truck containing bulk material. We have 3 sources, 1 for every type of truck, and then they're going to go through the following servers. First is the porter's lodge for a checkup process, then they're going to go through a weight-in process at the scales, and afterwards every truck is going to go to its respective unload station after a setup. So it's going to go setup and unload station. After they're done unloading, they will go back through the same porter's lodge as before, only this time they will have priority over the trucks that are entering the complex. And finally they're going to go out through this sink, which represents going out of the complex. Once we had all the information, putting the model together was actually pretty easy. We just had to input the information of the distributions for the arrival times in the sources and the processing times in the servers. Some things that we did different was we decided to set up animation with the colored trucks and also a visual indication that the truck is gonna exit, which is a black truck. So the black truck is going on exit and it will have priority over those that are going to enter the complex. So in order to set priority, we set it on the exit nodes, so you can see that exit priority with a value of 10 and an entry priority which has a value of 0. So on the porter's lodge, the one with the highest priority will exit first. And finally, instead of using a fixed capacity for every one of our servers, we created properties. That way we can change them while running experiments and come up with an optimal solution. This is how we set up our experiments. We run a lot of experiments. This was the last one. We noticed pretty quickly that the original configuration is actually pretty optimized as far as the unloading stations go. So that's why you see all 3s, because if we tried to move these ones, the model would be either not efficient or not capable. So the sweet spot is basically the original configuration. However, we did see some improvements regarding the scales and the porter's lodge, which we will discuss in the results.
In order to verify the model, we compared historical data with the simulation data. For the model to best fit the real system, we obtained a variation of both data. The error percentage is very low, so we agreed that the model is working as planned.
Once we ran our experiments and analyzed the results obtained, we agreed that scenario 2 was the best scenario, and it was an upgrade from scenario 1, which is the current system. The reason being is that in scenario 2 we keep virtually the same capacity as the current system. However, we do this with one scale less, which represents less operation costs.
Therefore, the simulation model was satisfactory. In behalf of our team, we want to thank P&G for collaborating with us. Thanks for your attention.